Okay, let's try our hand at simplifying some rational expressions. This, as it's written, doesn't give us a lot of hope, but we have a division here which we should attend to, and hopefully doing that will allow us to cancel some stuff. So we have this first section with the x minus 2 and the x plus 3, which doesn't change in any way. This division turns into a times, and what comes after the division flips. So we get our x plus 3 upstairs now, and our 2 times x plus 1 goes downstairs. The x plus 1's cancel, the x plus 3's cancel, and so when that's all over, we still have an x in the numerator, and we have 2x minus 2 in the denominator. So that's our simplified version. There's nothing else that we can cancel in this case. Now they also want restrictions on the variable, and for that we have to backtrack. We have a number of pieces to look at. In our denominator we have x minus 2. So one of our restrictions would be x minus 2 must never be 0, which means x must never be 2. From this next term with the x plus 3 in it, we get x plus 3 can't ever be 0. Therefore, x can never be negative 3. Over here, we have simply x, so x can never be 0. And I don't have to simplify that, that's done already. And we get x plus 3. Well, I already covered that one. That's just going to tell us that x can't be negative 3 again, which we already knew. So, that's all our non-permissible values. Or is it? It's not, because another thing happened. In this next line, we flipped this fraction over and we got some new stuff in the denominator. We got 2 can't be 0. Well, don't worry about that. 2 never is 0. We only care about the parts with variables in them. We also get x plus 1. So we'd have to say x plus 1 is never allowed to be 0, which would mean x must never be negative 1. So those are our 4 NPVs. Ew, 4-level stacked fraction. This means, this line should be drawn a little bigger usually to make this clearer. This means the top divided by the bottom. So this actually means 4x plus 12 over 3x plus 12. That's the numerator part, divided by, and now our denominator is the 3x squared plus 9x over x plus 4 all squared. Now, in the first example, they factored everything for us. In this one, they did not. You can see we've got a common factor on our 4x plus 12, also a common factor on 3x plus 12, and there's a common factor hiding in this quadratic as well. So let's take care of those. We need to be able to see what can cancel and what won't. And that's hard to do when things aren't factored properly. So 4 comes out of this first part. 4x plus 3. 3 comes out of the denominator. Leaves us with x plus 4. Divided by 3x can come out of that numerator. That leaves us with x plus 3. And in the denominator we have x plus 4 squared. Okay. Now we're told to divide. I'm not going to. I'm going to change this to a multiplication and flip the second fraction. So we have 4x plus 3. Nothing happens on the left-hand side. This is just scribing. Times the x plus 4's go upstairs. And the 3x and x plus 3 go downstairs. And now, as we hoped, a bunch of stuff cancels. The x plus 3's cancel. This x plus 4 cancels one of those x plus 4's. And so now we have 4 x plus 4 over 3 times 3 is 9. We have an x, and that's it in the denominator, I guess, just 9x. So, NPVs, now that we revisit this thing, I'm going to work with my factored version here because it's easier to see NPVs when you have everything pulled apart. 3 equals 0, never happens. X plus 4 can never equal 0, therefore x can't be negative 4. So the 3's covered, the x plus 4's covered. We have x plus 4 2 more times, but there's no need to solve that. It's going to give us the same number again. And then after the flip, we have 2 more contributions. We have 3x can't ever be 0, which means x can't ever be 0. And we get this x plus 3. X plus 3 is forbidden to be 0, which means x can never be negative 3. So our complete list of non-permissible values is negative 4, negative 3, and 0.